Right, the first part of this question, question 1, says plot a graph of distance s versus time for the first 10 seconds of motion if u equals 10, well I've come up with some other numbers actually, 8 meters per second,
that's one of the bunch of
and
equations.
a for acceleration is 4 meters per second. So what we need to do, we're going to plot a graph, so we need to come up with a table. So if I just do a quick rough and ready one. So T. So.
What way? No. Where are you laughing at? Tell me now.
So we'll just squeeze in with 10.
Oh. Okay.
So I'm just going to do 2 columns here. I'm going to do my workings. Or rather, you're going to do the workings. I'll put some in. And then the total. So this is at total x, how far you've travelled. Not how far you travelled, but how far you displaced from your starting place. Then we're going to plot a graph of it, yeah?
Yeah.
Right, grab your calculators.
Wait for my birthday to come through.
I'll give you an example. I'll give you a few examples. The first one, for example, you listening? Your first one, if t is 0, what's it going to be at time 0?
0.
How far have you travelled?
0.
Yeah, we've not made any distance at all.
Oh, listen, what the hell? Give me that.
Okay? So, concentrate because you're going to help me with this. The second one.
I said you have to draw though.
Yeah, you've got to do a table. When you do the assignment, you have to do a table. Do it neater than mine, use your rulers, etc. It don't have to be quite laid out like this, you can just go from your t to your total. Do you understand what we're doing here? We're putting our values in here into this formula, and we'll end up with a graph. Okay, so when t is 1, that's going to be my u equals 4. No, it doesn't, it equals 8. A equals 4. So that's meters per second. And that's meters per second what?
Squared.
Squared, yeah. Per squared, yeah. Per squared. Okay, minus 2. So at 1, it's going to be 8 times 1 plus 1 squared is 1 times 4. Half it's going to be 2. So it's going to be 8 plus 2, which is what I'm putting here for. Right, do you want to give me some figures then? How many we've got here? Enough to do. Who's got calculators?
So 16 plus 2.
Those with calculators.
Is it 16 plus 2?
16 plus 2, this one.
Yeah,
No, because it's 1 times 8, that first one. This one's going to be 16.
I told you.
And then it's going to be plus, so you've got 2 squared.
Oh shit, that's it.
A tip for you here, a tip, guys, save time. A tip, this A is 4 times a half, so you just change that to 2. So it's going to be the number squared times 2 every time. So that's a bit quicker, rather than doing the whole lot. So this will be 24. Okay, right. Throw some values at me.
42 next one.
42 next one. Right, you've done one. Your turn. You've got a calculator there.
50.
Have you got a calculator? So let's see.
64.
Adil, you do last one. Number 10.
64.
64.
64, Zuling.
Are you okay? So next one. Adil, you do this one.
10.
Last time you do next one up. 9.
It's 5 9er.
Say again.
10 times 8 is 80.
90.
90. Is this 90? Right.
The 9er.
I've only done up to 7.
Is Paul ever wrong? How can you question?
Times it by.
So for the sake of speed, but I haven't got the other 3, so it's over to you guys.
Alright.
Because I ran out of time.
Times it by 4.
Sorry?
I don't know.
192.
You need, if you
192.
do it in your head, do it in your head. I did them on.
192.
192.
Oh,
Somebody else not done any.
234.
234.
234.
Nothing any.
And the deal that was doing last one, weren't you?
300.
Yeah, that's 80.
80? If you spot a pattern here that tells you that 80 might not be correct.
Pattern.
A pattern, look.
What did they all get?
42, 42, 42, 42. Then you go back to 0, it'll be 300 or something. Oh, yeah, it's falling now again.
Huh?
It's hard
282.
Yeah, 280.
380.
280.
280.
Now,
Now 280 I can believe.
0, 0, 4, 2, 4, 2,
Right, next step.
4, 2, 4.
When you do this, you do it neatly with a ruler.
The baby tables, man, you have to put your elbow looking there.
Okay.
Yes, you did. 280.
Don't forget to label your axis.
No, it's not.
Don't forget to label your axis. Don't forget to give it a title.
Oh yeah, title.
What do you think's a good title?
No, 154. What the fuck with that one?
What do you think's a good title?
What is that?
Good title for this graph.
Oh, Kevin's graph.
Kevin's graph, yeah.
Yeah. Graph.
Kevin's graph or displacement against time.
Yeah, yeah, yeah.
I beg him, John.
Against time. A graph without labels on the axis and usually a title is essential. Okay, so I'm going to go to 10. So, very rough.
I'm trying to concentrate with it.
Okay, something like that.
Are we drawing the graph as well?
Why are you messing about for?
A lot of chatter going on there.
About the work, sir.
That's that. Right, up to 10, because we've got up to 10 seconds. And then we've got to get this scale to 280, so it's a bit tricky. So we need something like 300 there.
Go up in 50.
So we're going to have something like this. Obviously, do it on graph paper, do it neatly. Do it neatly, put your scales on. So mine's a bit rough, yours won't be, yours will be perfect, won't it? Okay, especially those who think they're getting a distinction. Okay, let's have a look. So the first one is 0. That's easy. It's not travelled any distance in 0 time. Then it gets to 10. So that's going to be somewhere around here. Yeah? Then it gets to 24. Somewhere around the middle. 42. Something like that. 4 is 64, so somewhere about there-ish. 90. Then 120. Then 7 is 154. Wow, that's a big increase. Then 192. Two, three, four. 2, 3, 4.
Can we go by that kid? You need that
Basically,
and 280. Somewhere like that. Okay? Because the maths is pretty precise, you would actually get a proper curve, but mine's a bit, because I'm not using graph paper, it's a bit all over the place. But then those would join. Okay, missed a few dots, freehand. Guys, missed a few dots. So what's the thing? That's terrible. What's the thing with this shape? What's it doing?
It's curving.
It's going up, it's increasing.
It's increasing, yeah. I mean, it's right. The distance it's travelled is going to increase, even if it was linear. But what's significant about this one? It is, yes. It's getting the distance travelled is increasing each second. It's not linear. Okay, because you've got a square there connected to acceleration. Okay, right. Easy enough that. Just a bit messy, a bit time consuming, but not bad. You can all do that. You've all done that before.
Yeah.
Right, it gets interesting now. Next question is, determine the gradient of the graph at t equals a seconds and t equals b seconds. So you're going to find two gradients off the graph. Change of colour, I think, here. So I've chosen 1 second and 3. So I've gone with 1 and 3 because they're not in your student data. So I've chosen this one and this one. Probably should have spread it a bit more, but anyway. So how do I find the gradient for that one and how do I find the gradient for that one? Pardon? How do I find the gradient for these two marks here?
Now y equals mx plus c.
Yes. Yeah, that's where we're heading. We're heading
Take a point from y and x.
we're going to be using that, are we not? Rise over run.
Yeah,
But-
like a triangle thing in it.
That's it, like the triangle thing, so that's what it's often put. But, you get my little... So what I do is I put my line of best, what I think's best fits, what I think's represents it.
The line that can cover the most points in it.
Right, well we've got to put a straight line on to do this rise over run.
Yeah, you have to try to get it through more.
But we've got to think of, we're not joining our dots up with a straight edge because it's curved. Okay? So we've got to work out the gradient at this point as best we can. So all I can do, I mean it's fairly flat there because it's a bad because I'm a bad drawer. If that's a proper verb.
Do the thing and then
And here, something like that. Okay? Those two are probably very close together. So if I take this point here, this here, and this here, take them down, take them along. This is going to be a lot easier on graph paper. Take them down, take them along. So this is going to be my y2, this is going to be my y1, this is going to be my x2, x1. So I can take those numbers and put them into my formula. Okay with that?
Yep.
Is that easy?
No, it's like not very
It's
precise.
tedious actually. It's tedious.
Nothing's easy in life.
That's the beauty of calculus, it makes life easier for us. We like to make life easy, don't we? So,
So did you just say it makes life easier?
calculus, yeah. This is not this is not hard, it's just a little bit dull.
Yeah, yeah.
Especially when you do it twice. So I'll get some answer, I don't know what it'll be, I'm not gonna do that. I'm not gonna
Not Spider-Man.
I'm not going to do that. Right. Okay, so I find my gradients for them. So that's question 1A done. Right, question 1A, B. Question 1, section A. B says this. Differentiate the equation to find the functions for the velocity and the acceleration. And this we haven't done quite yet. I've mentioned it. Right, have you all got this down, those who want it, because I'm going to rub it all out.
The really big graph.
Huh?
The really big one.
Yeah, I'm going to rub it all out.
Do we need hands on now?
No. You've got the gist of what we're doing.
Yeah, I've got
Okay. Can I rub it out?
I've got the
Yeah.
One second.
Get the cameras out. Okay.
My side to
Yeah, the fucking media, man.
Yeah, you can see mine. Right.
Yeah, that's not good.
What? You want the gym? I've got the gym. Is that your gym?
No, but
Can I rub it out?
Yeah.
All done?
It's done now. No, the bad boys are spoiling, you know. The bad boys spot on. Come on, make sure.
Everybody
Come on,
Right. Next thing says this. It says differentiate the equation to find the functions for velocity. So we've got this. We've got the equation for D. And I've got to find the formula, well, the expression that represents velocity. So velocity is equal to the displacement of S against time. Okay, remember I said that's one of the reasons for differentiation. It gives you an expression to find the gradient, which will actually tell you what the speed is in 2 seconds, 5 seconds, a million seconds. Okay? So what I've got to do is I've got to differentiate that. So if I put my numbers in, I've got, let's do it over here, if I can squeeze it in. You listening?
Yeah.
Yes, sir.
It's a bit messy that, let me just tidy that up. T. So this I'm going to simplify. What's 4 times a half? 2, yeah. So I'm going to make that into 2t squared. Don't forget squared. Okay? That's a bit simpler to work with then. Right, so if I differentiate that, what am I going to get? And it's as easy as everything we've been doing. So don't look at it and think you're missing something. It's straightforward. So what's the differentiation of 8t?
Just 8.
Just 8, yes. What's the differentiation of 2t squared?
Just
2
4.
squared.
40.
No,
40.
4t, yeah. Well done. Not 40, but 4t. 40. Okay. So the squares become single now. That's it, it's done.
That's it.
So that's an expression. So now I can find the velocity at any time. Excuse me. At any time in history. Any time going forward. Shall I say? Any time you wish. Okay. I could possibly do it. Well, going backwards is a bit strange, but that's one done. The next one is find an expression or an equation for acceleration. Now, acceleration is A, which is two things. It's dv dt, or this you haven't come across before. This one, d2s dt squared. So this 2 means it's differentiated again. That's all it is, it's this differentiated again, and that will give us acceleration. Okay? Straightforward enough? So I'm going to differentiate this to get an expression. So what's the differentiation of 8? 0, correct. 4t? 4. So, done. The acceleration is 4. Okay? Which makes perfect sense, does it not? It's not accelerating, it's got a constant acceleration. But it changes, because he's squaring that, it makes your distance get faster. The distance you covered get greater and greater each second. the difference. Okay? Right. Next bit says, use your results from part B to calculate the velocity at those two values we were given earlier, which was 1 and 3. So what that means is, take this one, let's change colour. So 1 and 3, you're going to do, so you're going to end up doing it for, you're going to do 4 equations. So you're going to take this one and you're going to say 8 plus 4 times 1, that was your value of A, and that will give obviously 12 meters per second. So that's your velocity after 1 second. What's your velocity after 3 seconds then?
5.
So that's one velocity. Our second velocity is
24.
8 plus 4 times 3. Yeah.
20.
And then that'll be 36.
12 and 8.
Oh, it'll be 20 then.
20,
Or
yeah.
you have to use odd big mass or something.
No, just do it. You just put the numbers in and put it in your calculator. I'll do it in your head in this case. Okay? And then the next one, as you say, yeah, it just says do velocity. Then it says compare your answers, so you're doing two equations. Compare your answers. So you remember when you did it on the graph? Compare them two results and see if they're the same. Now what would you do if you're just doing the pass, maybe even the merit? You're not going to go into much depth, but if you're doing the distinction, you're expected to explain. Like, why would it be different? I've got 12 and 20. What happens if I got 11 and let's say 17 when I took it off the graph? Could be even worse.
So 3 seconds over there.
That's 1 out, that's
So it's like
3 out.
see the equation there?
What would you
8 plus
discuss in your assignment if you're doing a
So if you
distinction?
want to find the velocity
You
at
got
that
it
point,
wrong.
you just substitute the time.
Have you got it wrong?
No.
It evidently is wrong. Which is the most accurate method? Which is the one that's right?
Calculus or the
Calculus, do you agree?
calculus.
Everybody agree with that?
Yeah.
Everybody agree?
Yeah, I agree.
So what, does that make the graph wrong?
It don't make it wrong, you know.
It's not as accurate, is it? It's not. If you've got these figures, it's not totally wrong, is it? It's probably better than the weather forecast.
It's an
anyway.
estimate.
Yeah, it's an estimate. Perfect, it's an estimate. So just comment on the differences. Okay? If you're aiming for the higher marks. Simple as that.